Hello everyone, I'm going to go ahead and get us started. I would like to go over this question here. I had a student actually email me saying that the video provided wasn't very good. I value that feedback, so I'm going to go ahead and make my own video, and hopefully that will be sufficient with it. So what we have here is a transformed logarithm that's graphed out below, and then it goes through a couple of significant points. So the vertical or the horizontal intercept here is at -2, and then it also goes through this point 3, -2 as well. In addition to that, it's a logarithm that has a vertical asymptote at -3 there. So when we're stuck on these things, I want to remind you a couple of pieces. Of course, right, when we have this, we can bring up our textbook, and this is a formula that we have here. So our logarithms are going to meet this form, unless of course they're decreasing. So let me give you an example. The one right above this is an example of a decreasing logarithm. Okay, and when it's decreasing, we are going to be using this formula instead. Okay, so since in my case, what I have here is a function that's decreasing, but it's concave up, what I'm going to end up using is this first function here. So if I go over the pieces, oh, you can see me practicing here. This is what my function is going to be, where this b is going to be my horizontal translation. So in this case, it's going to help to know where my vertical asymptote is. So since I know my vertical asymptote is here at -3, that means b is going to be -3. So if I replace this part already with a -3, I see what's going to happen here is that these negatives will cancel out, and I have a +3 there. Right, so that's how all of you will end up using that vertical asymptote. I would recommend doing that first. Now we're going to use our 2 points here, -2, 0, and 3, -2. So in this case, we have -2, 0, and then we have 3, -2 there. So we know that it needs to hit those 2 points in order to make it work. Well, also, if it helps, let's create a little bit of a visual here, having x is -3 here, and I'll even make that a dashed line, so that way we know that. So we know it's going to be decreasing yet concave up through these 2 purple points, if you would. So essentially what we're doing now is, algebraically speaking, is we need to find a and k here. And we're going to use one bit that is a pretty useful property, and that is log of any power to 1 is 0. So if I can get this to turn into log of 1, then that means this whole block will turn into, this whole block right here will turn into 0. Well, I mean, this -2 is what I need to make that work. So what I'm going to do is I'm going to plug that in here, and then I'm going to replace x, well, I'm going to take f of -2. And that f of -2 is going to have to take me to 0 in order for this point to exist on it. If we were to do this, right, again, that -2 plus 3 gives me 0, which, that -2 plus 3 is going to give me 1, and that log of 1 is going to give me 0. So this whole thing is going to be replaced with 0 like that. I don't know why it doesn't want to get rid of that. But we can see that this is really helpful because that means we have a times 0, so that's 0 here, and then that 0 plus k means that k is 0 off of it there. So it tells us what value that needs to be. Now, in order to find a, all of you are going to get a not so great result off of it, right? So but how we're going to do it is we're going to plug in this next result here. So if I were to take this and instead plug in the 0.3 negative 2, well, algebraically speaking, that's what this means here. We would replace this part with 3. X is replaced with 3 there. So what I get is log of 6 left over, right? So logarithm on its own is going to be an increasing function where we have to, right? Normally at 1 it goes to 0. If we go all the way over to here to 10, that's going to be where it gets to 1. So log of 6 is somewhere in between. That's right here, right? In this case, it's going to give us 0.778. Okay, so it's actually going to give us something that is not done at 0.778. It's going to be this much larger figure here. So how do I deal with that? Well, I would leave it as log of 6 because this is not a great number, but it's still a value. So I can divide this over. So I can divide it over here. And then I now know what a is going to equal. Okay? Now you can see that what we have here is it's going through the 2 points it needs to. It's got this vertical asymptote here. Everything kind of worked out for us. So that's what it is. Now, one last point. When I'm plugging this into a program, remember that this is not going to be a human being that's looking at this. So you want to be careful with how you enter it in. And notice that this first block here, this is really, right, this times log of x plus 3. So I'm going to put it like this so that way it knows to read that this whole block on its own. And that what we have is this is our a, and then here's our logarithm with it. Right? Now one final point, if we click on this, notice that I get the exact answer that I have here. But notice that it says negative 2 log base 6 of x of 3. And this looks pretty nice. So what I'd like to do, right, like you have enough to complete the problem as it is. But I'd like to talk about, well, why is it that it has such a nicer answer compared to what I had written there? And essentially what we're going to do with this is we're going to look at just this part here. And instead we're going to move that log of 6 over here. So what we have is this negative 2 kind of looming on the outside, and we have this log of x plus 3 over log of 6 here. And because this has the same log base, what we have is yet another property we can use. So that property is going to be if you have some log of a over b, and then you have yet another logarithm here. So if we have, say, log base a of some number, right? Let's say it's just 5 like this. Then what that means is you can rewrite this in terms of log base b of 5 over b like that. Okay, so essentially you can rewrite it in terms of what's in there. So in our case, what that means is that we can take this function and we can make it so that way this log base 6 is what's represented there. And then what's left here is log of x plus 3, which is what we have right there. All right, I hope this was helpful. By all means, give me feedback. If you find other videos that aren't very helpful, I'd like to know. I'm more than happy to record more of these and support you as you need. All right, hope you're doing well. Have a good day.